Hello friends, I'm Rashid and today I will be explaining you a unique data analysis technique that's called process behavior analysis. This process behavior analysis was invented at AT&T Bell Laboratories in early 1920s. So essentially there are two formula which calculates the upper natural process limit and lower natural process limits, and these two limits define the maximum and minimum range a data should vary in order to reflect its normal and abnormal behavior over the time. Okay, let's start it. We'll choose a blank template first and we'll take one example. The example could be any data, but we will take something which is relevant. Let's say we will draw something like this: date and production. So let's suppose we start with the month of June 2013, 2nd June 2013, and let's drag it. Before we start, we will first check the formats. So we will ensure the date formats and all those things are in place. So date and time, we'll check these things, something meaningful. Date, okay, this format is okay. Yep. Time, none. We don't need time. And okay, that's all. So now we'll quickly put formulas. So first we have to calculate mean. The formula is average of this whole column. Simple. Now there is nothing like we use in Microsoft Word or Excel, this drag thing. It doesn't work here. So this yellow bar, we have to drag it down. Yep. And cell decimals, let's make it 2 points. Yeah. Now we have to calculate run. So run is essentially the difference between two consecutive data points. So this is the absolute value, because run actually can come in negative values if the if the future data is less than the past data. So we will keep it in absolute value. So we will use ABS function, and then we will say the final value minus initial value, and this will be our run. Okay, so I'm doing the same mistake anyway. So this is the run. Now we have to calculate the mean run. So mean run will be a simple average of this column and drag it down, decimal place, keep it 2, and here comes upper natural process limit. So upper natural process limit will be equals to the mean value plus 2.66 multiplied by the mean run value, right? Just hit enter. So this will be the upper limit. It will be a constant factor because the mean and mean run will be a constant value. Okay. Lower natural process limit. So here is the trick, because we don't want any data to go beyond 0 in negative y direction. So We will calculate this as a function of max of any two value. Like the first value will be the formula, that will be this value minus 2.66 multiplied by mean run and 0. So if value is negative, it will always stay on 0. So the 0 value will come here. Okay, let's start drawing chart. So to draw chart, it's good to get a new sheet and delete this thing, and we'll draw the line chart because it's more appropriate. We'll say add chart data. We'll go to sheet 1 and we will select the chart value. Yeah, this value will select, and we need this production, we need mean value, we don't need run and mean run because they are not required to be represented on the chart. Upper natural process limit, lower natural process limit, and let's see. Yep, this is a beautiful chart. Well, there are quite a few information which we can conclude from this chart. It's a good idea to have shadow to make it more beautiful, but anyway, it's not required. So any data value which comes in between the upper natural limit and lower natural limit, it's supposed to be controlled, and anything if it goes beyond the limit is something which need investigation. So there are quite a few information which is reflected, like till June 6 the production was below mean, and it rises again, and it then have some zigzag pattern. Probably some of the good employee came to speed of the production, or managers put a lot of pressure on employees to get work done. So whatever the case be, so this is the way to draw these charts, and I hope you enjoy the video.